Hello YouTube and welcome to What the Math. In today's video we're going to be playing around with Universe Sandbox 2 and we're going to be creating a new solar system, but specifically we're actually going to try to copy the nearest solar system to our solar system, which is called Alpha Centauri. If you didn't know that, now you do. You may have heard the term Alpha Centauri if you've played Civilization. There's actually one of the games is called Alpha Centauri. That's when humanity ascends and decides to go to explore new worlds, and the closest world that they land on is Alpha Centauri. And this is actually, it's really interesting. It's a star, but it's actually a very tricky star. I'm going to show it to you when we start creating it. So let's actually go over here and we're going to go into the solar system simulation because it's already pre-made for us. So this is Sun, this is Mercury flying around really quickly, Venus, Earth is right here, and we have Jupiter and Saturn, and of course Uranus and Neptune. Somewhere over there there's Pluto. Now we are going to create a new star, and this actually in the Alpha 15.2 there's a lot of new additions specifically to how you can add new objects and make them orbit a little bit better with a little bit more stability. So now you can actually create things like binary system and triple systems and so on. And the reason I'm saying that is because Alpha Centauri is actually, it is the closest star to us, but it's also a binary system. Now how close is it? Well, let's find out. So we're gonna go over here. I'm going to type alpha and it will give me two choices. Because these stars are already pre-made. This is the exact mass of these stars. So Alpha Centauri, oh no, sorry, this is it. Alpha Centauri Alpha, or Alpha Centauri A, is the larger of the two, and it has a mass of approximately 1.1 suns, so it's about 110% more massive than our sun. It's also a little bit heavier, but it essentially looks just like our sun. It's orangey in color. It's, you know, warm and dangerous and scary. And but then there's also Alpha Centauri B or Beta, and this one is a little bit lighter. It's about 93% mass of the sun, but it still looks the same. It's still pretty much the same as our sun. Both of them are maybe about 1 billion years older than our sun. Now here's the tricky question. So how far is it from us? Let's actually, I'm going to visually help you visualize this. Visualize. There you go. That's the phrase of the day. Visually visualize. So let's take Alpha Centauri Alpha, and we're going to place it at exact distance as it is in real life. So I'm going to scroll out and just notice that this is the this is where Pluto is. This is the Kuiper's belt, or sometimes it's called Kuiper's belt, and right here there's the Oort cloud. This is where all of the comets are coming from, so you can't really see it in the game, but it's sort of here. So this is really far away. The Voyager 2, which is the farthest object, man-made object that is in space right now, it's somewhere around here, I think. So this is after like maybe 40 years of travel. It's somewhere around here, and we're gonna be going farther than that. We're gonna be going way farther. I'm actually gonna so you can see that we're still over here, and we're going away at a distance of approximately 4.37 light years away. So right now it's in astronomical units, but it's going to convert itself to light years in about a second, because this is actually really far. We are going to go really far, which is why we have never been to that star, because it's so far away. So right now you can see there's a it's at 1.4 light years, still not there. Still gonna keep going to until it gets to about 4. There we go, 437-ish. That's close enough. So that's our Alpha Centauri A. It's right here. So let's go back to it. Let's zoom in. Try to zoom in. It's kind of difficult. There we go. Oh, too much. Now, it has a binary partner. It's a binary star, so it has a partner, which is Alpha Centauri Beta. Now, the distance between them is not very great. It's actually just about the same as the distance between Sun and Saturn at its closest, or Sun and Pluto at its farthest. So that's about, let's just say, about 20 astronomical units away. So the binary partner is about around here-ish. Ta-da! Now, what I didn't mention is that we now know that there's also another star in that system, but it's tricky because we're not sure if it's part of it, or if it's just hitching a ride, or if it's like just passing by and flying away somewhere, because we haven't been observing them for long enough time. So there's actually another star, so technically it could be a triple system. So of all things, the closest star to us is a triple system, which is actually absolutely amazing. Unfortunately, it's not shown here. It's called Alpha Centauri C, or I guess you can call it Gamma. But we do have something similar to it, and this is what I'm going to put in here. So what we know about this third star is that it's not an actual star, or it is a star, but it's a brown dwarf. It's basically a star that never really developed into a fully grown star. And if you want to find out more about types of star, there's a video I posted maybe a few months ago that explains the different types of stars. So you may want to watch that just to find out what brown dwarfs are and what I'm talking about. But this one is actually kind of far away. It's somewhere around like maybe 15,000 astronomical units away, so it's actually sort of far-ish. But it is possibly orbitally locked with the main star, so it's actually orbiting around it. It might take it something like, I don't know, maybe 500,000 years to orbit around it once. But it is definitely orbiting something. So it's around here-ish. So there you go, that's actually Alpha Centauri system. I'm gonna possibly rename this from Wolf to Alpha Centauri C. So there you go. And it's about this same mass as Wolf here, except it's just, you know, it's a little bit different. So there you go. So this is actually the system. It's a very interesting system. And even though it's so close to us, it's actually the closest system we can see with telescopes. We don't really know much about it. People have taken actual photos with their actual cameras, digital cameras, that show that the double system and the third star kind of faint in the distance. But that's really all we know about it. Most recently, though, people have started to discover what seems like planets around it. So we know that there's possibly at least one planet. Unfortunately, for those of you who like Alpha Centauri, the game, where you get to colonize a planet, you'll be really disappointed to find out that this star, which is also actually same mass as Earth, it is very, very close to the mass of Earth. So I'm going to actually put Earth in here. Or should I put Venus? No, it's about Earth size, so I'm going to put Earth. But here's the problem, though. It's super, super, super close to the main star. It's about, it actually takes it only 3 days to orbit around it. And that basically means that 1 year is only 3 days. And actually, oh, what am I doing? I know there's actually an actual star here that is called Alpha Centauri something, right? Sorry, not a star, planet. Yeah, there you go, Alpha Centauri Beta. So this is about 1.13 masses of Earth. I'm going to put that instead. And it doesn't show, it only shows the distance in kilometers, but it's at a distance of about 2% of a distance of Earth from Sun. So that's about something about like 20 million kilometers. So somewhere around here-ish. There you go, that's good enough. So there you go. So what is the problem with that? Well, you can imagine it is pretty toasty there. And we're gonna just pause the game for a second. Let's actually slow it down. And let's zoom in. Let's actually zoom in on this planet. Okay, there's a little bug in this game where you can't really click on certain objects. You have to do this first. You have to click on chart. And, oh, might as well show you what this is. So, so this is a comparison of all of the objects in our solar system plus the one we just made. So right here we have Jupiter. Earth is... Where's Earth? Hello, Earth? Earth is right here. Earth, so this is our other planets. This is the Alpha Centauri C. So you can see it's about the same size as Jupiter, except that it's, you know, it's sort of in a transition stage toward the star, but you just never made it. This is the Alpha Centauri Beta. This is a second star. This right here is the Sun, and this is the Alpha Centauri Alpha. Okay, let's hope this works now. I hopefully can click on this now. Yeah, perfect. So that is the planet, and if you were to zoom in on it, let's see if there's anything on the surface. Yeah, there you go. So that's steam. That's basically how steamy and toasty it is. It's super, super, super hot. It is currently 597 degrees. According to astronomers, I guess, not astrophysicists. According to astronomers, the actual temperature is approximately 1200 degrees Celsius. So if there is anything on this planet, and if it survives, it's probably extremely hardy. It's probably not something you want to mess with because it can survive superheat. So that's essentially the only planet that we kind of think is there, but it's still kind of questionable because we're not sure if it's really there. But if it is there, it's really, really close to the star. I think about a few months ago, in March 2015, there was another discovery of possibly another planet, but also still too close to the sun, to Alpha Centauri star, which still means that it will be too hot. So we haven't really seen anything at a distance where it would be habitable. So far, there's very little hope for having a habitable star in this particular system, and which means that if we go to colonize it, this particular system, we're not going to be very successful at finding anything good there. But what I wanted to see is, you know, let's just stand on the surface for a second. We're going to press C and stand on the surface, the super hot surface, so watch your feet, you might burn them. And let's look at the stars. Let's look at what the stars look like. So this unfortunately is a little bit zoomed out, so it's actually, it would be much larger. In reality, it would be about this size. I don't know if you can see my pointer right now, but you should hopefully see it. So it would be about maybe like a fifth or a sixth of the screen. So it would be a little bit larger than that. So this is the main star, and then we have a secondary star somewhere out there. Where is the secondary star? Let's look for it. Okay, there it is. Yeah, it's a little bit farther away. So this one would be maybe something like half of the moon in the sky, and Alpha Centauri C you would probably not see at all. It's way too far. It would be just impossible to see. It would be very dim and barely visible. Whereas our sun, our solar system sun, would be just as bright as Alpha Centauri is from our planet. So you wouldn't be able to see it easily with a naked eye, but if you had binoculars or a small telescope, it would be pretty easy to see it, because it's not a particularly bright star, but you could definitely see it. On a dark, if it's like a really dark night and your vision is pretty good, you can usually see it as well. But you know what? I'm having trouble finding sun, even though it's supposed to say sun on it. Let's just actually look for it. Hey, look, all three of them in the same region of the sky. That's pretty cool. That's very unusual. Oh, there you go. There is the sun. So what you're seeing is actually, there's a lot of orbits that are showing. So if I were to remove the orbits, you would probably not see anything. Let me just try this for a second. So I just deleted all trail data, and I'm gonna delete all particles and all the dust. So okay, so it's a little bit visible, but it wouldn't be as bright as it shows in this game right now. So it wouldn't be as bright for sure. So yeah, so this is essentially what it would look like on this steamy planet, and what this system would look like if we were to ever visit it. And just to kind of give you an idea of how far away this is, let's actually just try to go back to our system. I may have to try to enable the grid so that you can see it. So remember, this distance right here, this is like from our sun to Saturn-ish, maybe a little bit farther away. And I'm gonna actually, this is gonna take me forever. Let's actually zoom out a little bit more. There we go. That's probably a little bit better. Let's try to fly back to the sun. Let's see if we can make it. Actually, I don't think we can make it. It's gonna still take forever. And remember, this is 4 light years away, which means that for the light to travel to our sun from here, it would take 4.37 years. Okay, now I think I may be able to do it. Yeah, there we go. That's a little bit better. No, still not good. Okay. I have to zoom out even more. I have to zoom out even more for me to be able to make it back to the sun. Okay, that's good. So now we're traveling back. This is like at crazy speeds of like hundreds times speed of light, possibly even thousands times the speed of light. And we finally made it back to our solar system. In the future, maybe this is some sort of a crazy faster than speed of light traveling device. And we are back. Okay, so there we go. So this is how far away it is. And if I were to zoom out again, just to show you perspective from the side, and this is Neptune, this is Sun, this is distance from Sun to Neptune. Zoom out, 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 zoom out. And the closest star is right here. So you can imagine how crazily far this is. If we were to try to fly there with a normal spaceship that we have today, even things like, you know, same spaceships that landed on the comet a few months ago, I'm talking about the Rosetta mission, or the spacecraft that just visited Pluto in June of 2015, it would take us something like maybe 3,000 or 4,000 years to get there, just, you know, fly in a straight line. So it is pretty far, possibly even longer than that. I think it's actually longer than that. Now, what I wanted to also do is to see what this would look like or no, what it would look like from our solar system if at the same distance we had a much brighter, much larger star. So you know what, if our closest neighbor was not Alpha Centauri but something a little bit bigger, let's actually experiment here. I'm gonna erase this completely, and let's go to the stars and choose something really big. So for example, we have things like Rigel, which is a very large, very bright star, and then we have things like VY Canis Majoris, which is probably one of the largest stars we actually know, physically the largest star. I'm going to show you how big it is by first placing it. Let's place it around 4.37 light years away. Right about here is good. That's number one. Now let's also place something else. What else can we place? So let's place Betelgeuse, because that is always fun to say, especially if you watch the movie called Betelgeuse. And let's just place it right here. And then we're gonna also place Rigel. Rigel or Algol? Algol is brighter, but let's place Rigel, because I kind of like Rigel better. So right about here as well. So now we have 3 stars, very large, very bright stars orbiting at the same distance as Alpha Centauri. We're gonna zoom back to Earth, go to our beautiful planet. Hopefully it's still around, because sometimes in this game, in the recent alpha, things disappear if you accelerate your time too fast. They sometimes disappear, which I learned the hard way when my Mars mission disappeared completely. I was trying to terraform Mars and it was gone. Okay, there we go. Earth is still here. But I'm experiencing the clicking bug again, so I have to do this. I have to click on chart again, but when I click on chart, if you've never seen the size of those stars that I just put in there, you'll be pleasantly surprised. So let's see what this is. So let me okay, so I'm gonna move back for a second. I'm gonna move back just to give you kind of a perspective on what we're dealing with here. Okay, where are we at? Where's my other star? I'm going the wrong way, aren't I? Yes, I am. Alright, so we are going this way. Here we go. Is that it? No, that's Rigel. What is happening here? Where is Earth? Alright, so this is a size comparison. This right here is the largest star that we know currently, although possibly something larger has already been found, but this is a star that is absolutely massive. I'm gonna put it in our solar system just to give you an example of how big it is in a few minutes. This is a very bright star called Rigel. It's much smaller, but it's much brighter. This right here is Betelgeuse, also a very large star, but not as big as Canis Majoris. And as I move closer and oh, there we go. They're so tiny. As I move closer and closer, you will notice that we now see our sun, which is right here. Sun is right here, and then here we go. This is Earth. Finally found them. They're so tiny I couldn't find them. Here is Earth. There it is. So there we go. So this is how massive, crazily massive these stars are. Let's actually take a look at what it looks like from the night sky if we are standing on Earth. Now, it's not going to be very difficult to find them because they're so massive, but I may still have to look around. So, where are we looking at? Okay, so let's start with this side first. I'm going to stand in South America. No, come back, Earth. Don't fly away from me. Come back. I say come back. Alright, so we're on the surface right now. I may have actually start time because I paused the time for a second. And okay, let's look at this. So this is sun. It's actually, like I said before, it's supposed to be much bigger, right? Because you've probably seen sun in the sky, so it should be about maybe 3 times the size. This would be Rigel. This is the bright star that I mentioned before. So it's not as big, but it would be maybe about, I would say, quarter of the moon, but much brighter. It would actually be very bright. You would be easily able to see it, even probably during daylight. So it's a very bright star, very easy to see if it's that close to you. Now, where are our giants? Let's look for our giants. Are they on this side or the other side? And there it is, I found it. So there is our Canis Majoris. And if you just compare this size, so just, remember the size here with our sun. So it's about half of the sun. Even though it's so far away, it would actually be half the size of the sun. Now, whether it gives us just as much warmth, that's a question that I don't have an answer to, but it is definitely a very large object that would be easily seen from anywhere. So this is Canis Majoris, and Betelgeuse is... Where is Betelgeuse? Let's find Betelgeuse as well. Oh, there it is. I found it. It's right in the middle of Milky Way. So Betelgeuse is right there. So just like the Sun, sorry, just like the Canis Majoris, it's about the same size, maybe a little bit smaller, a little bit more dim, but it is a very, very large star. It would be easily seen from our planet, and you would probably be able to see it during daytime as well. So it kind of look like we have another star in our system, even though it's really, really far away. Now, how large are those two stars? So I'm gonna go here again, and I'm gonna pick Canis Majoris and just place it in the middle of our solar system. Let's see what happens. And so where is this? Where is the sun? Where is the sun? There is the sun. Okay, so this is essentially, it covers everything up to Saturn, I think? No, Jupiter. Everything up to Jupiter, almost to Saturn. Essentially, this whole star is larger than the distance from the sun to Jupiter. If I place it here, and let the time run, it is going to swallow everything, is it not? Let's find out what happens. The end is near. We are being swallowed by a massive star. Let's just accelerate time a little bit, see what happens. I'm guessing there might be nothing left. Is something going to happen? Okay, Saturn is burning. Other stars and planets are gone. And I think it's just basically vacuuming everything in, because suddenly there's this huge massive object in the middle, and I'm not sure if Saturn and Uranus and Neptune will be able to outfly or maintain the same orbital path. Okay, let's accelerate a little bit more. And oh, and we have supernova. We have supernova. That's because I combined too much solar mass. So now we have a beautiful supernova in the middle that is going to cover all of these stars, which is going to be absolutely gorgeous. That's actually a very good ending to this video. But essentially what I want to show you is how far away the closest star to our solar system is. Now, if you know anything about our galaxy, which I'm going to show you in a second, because there's a galaxy simulation too, let's just keep this running. See what happens when they reach the other stars. Oh, this is gorgeous. Look at how beautiful this game has become. And there you go. So after a few something like 15 years actually, the supernova will actually reach other stars, and they will be all covered by the remains of our sun. So it didn't even take that long for us for the solar wind, or whatever the solar particles these are called. I'm not actually sure what they're called. I guess they're called nova particles. For them to reach the other stars. It didn't really take that long. Anyways, so this is gorgeous and all, but let's actually take a look at something else. I'm gonna just stop this, because I think my computer is about to die soon because of the amount of particles that there are currently in this particular simulation. But let's actually look at a galaxy. Where is the galaxy simulation? Alright, so here's a simulation that has two galaxies that are about to collide. But what I wanted to show you is not collision itself, although we'll see the collision as well, but the actual distance that we just covered. So we were only talking about, what, maybe 4.5 light years away from our planet. So here you have to really zoom in to see how not far away at all it is in galactic terms. I don't know if you can see these two little dots, but this is possibly what it would be like. This is maybe about 4 light years away in galactic terms. So right here, this is what it would be like. Possibly even less than that, actually. And since our... so imagine if this is Milky Way, our planet would be somewhere around here, including Alpha Centauri. So not our planet, our sun. So our sun would be, I'll just pick something that's a little bit more visible, because a lot of these points are very dim. So if this is right here, if this is, I don't know if you can see the pointer, but if this is our sun, and this is Alpha Centauri, this would be 4 light years away, and here we go. This is how insignificant it actually is. So yes, we're really far away, and things are really far away in space, and this is why it's called space, because there's just so much distance between everything. Anyway, so let's see the collision. This is going to be the final part of this video where two galaxies collide, which is actually something that's going to occur eventually, because our Milky Way is headed toward Andromeda galaxy, and in a few 100 billion years, or basically sometime in the future. We're not really sure exactly when, but sometime in the future they're going to do this, just this. They're going to have a little dance. But the good thing is that for the Earth to actually smack into something, or not Earth, but our Sun to smack into something, the chances there are pretty low. So there's a very high chance that by this time our Sun is going to just burn out and do the whole supernova thing, and not actually live through this beautiful dance of the stars. Alright, on this note, I'm going to pause this video, and in the next video we're going to investigate something a little bit more closer to our solar system. But hopefully you enjoyed this, and if you did, subscribe, check out some of the other Universe Sandbox 2 videos that I posted, and leave a comment, tell me what you would like to see more of or less of, and we're going to make it happen. I also wanted to announce that I'm possibly going to start using Twitch TV on weekends. And I'm wanting to start with a game I actually started to really enjoy. It's a game called Hacknet. I actually just posted a review about it very recently, and I think it's a game that you can possibly finish in a few hours, which is absolutely perfect for Twitch TV. So if I end up doing it this weekend, which I guess if you're watching this in the future is possibly a weekend long time ago, then do tune in. It's going to be super fun, and I'm going to try to make it as enjoyable as possible. Oh, this is gorgeous. I'm also going to post the Twitch TV video later on my channel, so if you've missed it, that's okay. You'll get to watch it later on. But anyway, thank you for watching. I love you guys, and game you later. Bye-bye. Hey, look at this. It turned into one big mega galaxy. That's so cool. I didn't expect that at all. So this is the future of our galaxy. Game over. The end.